Hello everyone. Today we will see first part of Unit 1 Object-Oriented Programming and C++. In this part we will see about Object-Oriented Programming, paradigm, basic concepts of Object-Oriented Programming and benefits of Object-Oriented Programming. And in the next part we will see object-oriented languages, applications of object-oriented programming and a simple C++ program. First of all, we will see the object-oriented programming paradigm. Object-oriented programming treats data as a critical element in the program development and does not allow it to flow freely around the system. It ties data more closely to the function that operate on it and protect it from accidental modification from outside function. Object-oriented programming allows decomposition of a problem into a number of entities called objects and then builds data and functions around these objects. The organization of data and function in object-oriented programs is shown in the figure. The data of an object can be accessed only by the functions of the associated functions associated with that objects. Functions of one object can access the function of other objects. Now we will see some of the features of object-oriented programming. These are: emphasis is on data rather than procedure. Programs are divided into what are known as objects. Data structures are designed such that they characterize the objects. Functions that operate on the data of an object are tied together in data structure. Data is hidden and cannot be accessed by external function. Objects may communicate with each other through functions. New data and functions can be easily added whenever necessary. And the last feature is follows bottom-up approach in program design. Object-oriented programming is the most recent concept among programming paradigm and still means different things to different people. Now we will see about the basic concepts of object-oriented programming. It is necessary to understand some of the concepts that used in object-oriented programming. These concepts are: first one is objects, second is classes, next one is data abstraction and encapsulation, next one inheritance, polymorphism, dynamic binding and message passing. We will discuss these concepts in some detail one by one in this section. First concept we will see about objects. Objects are the basic runtime entities in an object-oriented system. They may represent a person, a place, a bank account, a table of data, or any atom that the program has to handle. They may also represent user-defined data such as vectors, time, and list. Objects can interact with having to know details of each other's data or code. It is sufficient to know the type of message accepted and the type of response returned by the objects. Here we define or describe the objects in two different ways. Two notations that are popularly used in object-oriented analysis and design. The notation A and the notation B. Here the object is the student and the data used in that case are the name, date of birth and marks. And the function that are associated with the object student are total, average and display. The attributes are sometimes called data members. The name, date of birth and marks are the data members of the student because they hold information, and the functions that operate on these data, that are total, average and display, are sometimes called methods or member functions of the student, that object. The next concept is classes. We just see that objects contain data and code to manipulate the data. The entire set of data and code of an object can be made a user-defined data type with the help of class. Objects are variables of the type class. Once a class has been defined, we can create any number of objects belonging to that class. Each object is associated with the data of that type, class, and which they are created. A class is a collection of objects similar type. For example, mango, apple or orange. These are the members of class fruit. Here we describe a fruit that create an object mango belonging to the class fruit. Now we will see about data abstraction and encapsulation. The wrapping up of data and function into a single unit, that is called class, is known as encapsulation. Data and encapsulation is the most striking feature of a class. The data is not accessible to the outside world, and only those functions which are wrapped in the class can access it. These functions provide the interface between the object's data and the program. This insulation of the data from direct access by the program is called data hiding or information hiding. Abstraction refers to the act of representing essential features without including the background details or explanations. Classes use the concept of abstraction and are defined as a list of abstract attributes such as size, weight and cost, and function operate on these attributes. The next concept we will see, inheritance. Inheritance is the process by which objects of one class acquired the properties of objects of another class. It supports the concept of hierarchical classification. In object-oriented programming, the concept of inheritance provides the idea of reusability. This means that we can add additional features to an existing class without modifying it. This is possible by deriving a new class from the existing one. The new class will have the combined features of both the classes. Polymorphism. Polymorphism is another important object-oriented programming concept. Polymorphism means the ability to take more than one form. An operation may exhibit different behavior in different instances. The behavior depends upon the types of data used in the operation. For example, consider the operation of addition. For two numbers, the operation will generate a sum. If the operands are string, then the operation would produce a third string by concatenation. The process of making an operator to exhibit different behaviors in different instances is known as operator overloading. For that, we will see in detail at the time of polymorphism. Now we will see about dynamic binding. Binding refers to the linking of a procedure call to the code to be executed in response to the call. Dynamic binding means that the code associated with a given procedure call is not known until the time of the call at runtime. It is associated with polymorphism and inheritance. In case of message passing, it is an object-oriented program consists of a set of objects that communicate with each other. Objects communicate with one another by sending and receiving information much the same way as people pass messages to one another. The concept of message passing makes it easier to talk about building systems that directly model or simulate their real-world counterparts. Now we will see somewhat benefits of object-oriented programming languages. Object-oriented programming offers several benefits to both the program designer and the user. The major advantages are: through inheritance, we can eliminate redundant code, extend the use of existing classes. We can build programs from the standard working modules that communicate with one another. This leads to saving of development time and higher productivity. Next benefit is the principle of data hiding helps the programmer to build secure program that cannot be invaded by code in other parts of a program. It is possible to have multiple instances of an object to coexist without any interference. It is possible to map objects in the problem domain to those in the program. It is easy to partition the work in a project based on objects. The data-centered design approach systems can be easily upgraded from small to large system. Message passing techniques for communication between objects and software complexity can be easily managed. Students, in this class we have studied somewhat object-oriented paradigm, basic concepts and the benefits of object-oriented programming. In next lecture, we will see about object-oriented languages, applications of object-oriented programming and a simple C++ program with some new features of the object-oriented programming. Thank you.